For the introduction, what is physics? Physics is the basic science because it is about the nature of the basic things such as motion, force, energy, method, light and heat, and structure of atom. Sir Isaac Newton, he formulated the three fundamental laws of motion and invented calculus. And Blaise Pascal invented the hydraulic pressure to multiply force. He also invented the siren. Calculus is a mathematical tool used to better understand physics and solve problems in physics. Physics explains us the nature and working of the physics element of the universe, and then we use this knowledge to enhance our life. The key concept in field of the physics that relate to calculus for this project is hydrostatic pressure and hydrostatic force. For the key concept, hydrostatic pressure is a pressure that is exerted by a field at the equilibrium at the given point within the field due to the force of the gravity. And second, hydrostatic force are the force on the body due to change in hydrostatic pressure on the weighted surface of the body as it moves from its equilibrium position. And the formula is force equal to mass times gravity equal to rho times gravity times area times d. And for the pressure is equal to force divided by area equal to rho times gravity times d. This helps us determine by the hydrostatic force against a vertical plate or wall or dam in field.
So the method that we use to find the hydrostatic pressure and hydrostatic force is by using the integration technique. Suppose that a plate submerged vertically in fluid of a weight density W runs from y equal to A to y equal to B on the y-axis. Let Ly be the length of the horizontal strip measured from left to the right along the surface of the plate at level 1. Therefore, the force exerted by the fluid against the one side of the plate is integration of A to B, the weight density times with the strip length times with the length of the horizontal strip measure with respect to y.
Example 1 is to show that this one is the shape of the trapezoid. The height is 20 meter and the one on the top is 50 meter and the bottom is 30 meter. We need to find the force on the deck due to hydrostatic pressure if the water level is 4 meter from the top of the dam. Yeah. So we are choosing a vertical x-axis with origin at the surface the water. So the depth of the water is 60 meter, and so we divide the interval into sub-interval is of the equal length with the endpoint x. So we choose x plus 1. The I horizontal strip of the dam is approximated by the rectangle with the height and the one W. So how we get the A is here and 16 minus because we got the 4 that and they are equal 10 and 20, so we'll get the A. So we need to find the W. W1 we got here is 15 plus A. 15 here, 15 and the A is here. A. So 2, 15, and we get the value of A is 8 minus 1 over 2x. So we put the W into this one because we know that P so if A is the area of the strip, then the A is y times x height equal 46 minus I. We don't know the height. If the height is x is small, then the pressure of P on the ith strip is almost constant, and we can use the formula, the pressure called the hydrostatic formula, 1000. So we can use this formula to find the force. So hydrostatic force is F acting on the ith strip is the product of the pressure and area. So we got the formula of F. So it's equal to Pi times AI. So 1000 GXI 46 minus x and times x. Adding this the force and taking the limit as n to the infinity, and the total of hydrostatic force on the dam is using this solution.
So I will talk about the example 2, and in this example we will find the hydrostatic force acting on the cylindrical drum. The circle equation given is x squared plus y squared equals to 9, and then the depth of the water is 10 feet. And then the radius of the circle is 3 feet. First, we will find the length of the ice strip. Given that this one, the length of the strip is 2 times square root 9 minus y squared, and then the area will be the length of the strip times the change of y. So we'll be given this, and then this is the pressure. This will be the pressure acting on the strip, and then the force acting on the strip is approximately delta di times the ai. Then the total force will be limit n tends to infinity 62.5 times 7 minus yi times 2 square root minus 9 minus yi change of y. And then we will integrate this equation, and then this will be so we will separate the two equations into these two equations, and then this is the integral of this equation is of function, so this value will be 0. And then we will do this one. This we will solve by using trigonometric substitution. Y equals to 3 sine theta. And then through the calculation steps, we will get the hydrostatic force acting on this cylindrical drum. The answer will be 12,370 lb.
Okay, in conclusion, calculus is a mathematical tool that used to better understand the physics, and the calculus is used to solve the problem in physics. And the key concept of our project is that the hydrostatic pressure and hydrostatic force. And once again, the hydrostatic pressure is the pressure that is exerted by the fluid at equilibrium at a given point within the fluid due to the force of gravity. Whereas the hydrostatic force is the force on a body due to the change in the hydrostatic pressure on the wet surface of a body. And the method that we use to find the hydrostatic force is by using the integration technique. And the results of our first example is the first example shows that the hydrostatic force on the tank is approximately 4.43 times to 10 to the power of 7 Newton. And for the second example, the hydrostatic force on one end of the cylindrical drum is approximately 12,370 lb.